Today I am explain about the multiplexer. Multiplexer means many into one. A multiplexer is a combinational logic circuit with many inputs but only one output. The multiplexer can be act as a controlled multi-position switch. The logic symbol of the multiplexer as shown in above PPT. It contains m into 2 power n input lines, one output line, and n control input lines. The output will be one of the input D0 or D1 or I0 or I1 or I2 so and In minus 1 depending upon the signals applied at the control input lines. A multiplexer with m inputs and one output is referred to as m into 1 multiplexer. Examples for multiplexer: 4 into 1 multiplexer, 8 into 1 multiplexer, and 16 into 1 multiplexer, etc. Now we discuss about the 4 into 1 multiplexer. The logic symbol of the 4 into 1 multiplexer is shown in above PPT. Here the 4 into 1 means it contains 4 inputs and a single output multiplexer with selector lines or control lines S0 and S1. In 4 into 1 multiplexer, I0, I1, I2, I3 are the inputs, Y is the output, S0 and S1 are the selectors or control lines. The truth table of the 4 into 1 multiplexer shown in above PPT. Here S1, S0 are the control inputs, Y is the output. So here 0, 0 are the inputs and Y0, I0 is the output. 0, 1 output is I1, 1, 0 output is I2, 1, 1 output is I3. So here S1, S0 are the control inputs and Y is the output. So based on the above truth table, we can design the output Y. So here Y is equal to I0, S0 bar, S1 bar plus I1, S0, S1 bar, I2 into S0 bar, S1 plus y3 into s0 s1. So these are all are adding with AND gate. So here as for the truth table, when s0 s1 is equal to 0 0, then the upper AND gate is enabled but all other AND gates are disabled. Therefore the data bit I0 is transmitted to the output and it is giving y is equal to I0 S0 bar S1 bar, and when S0 S1 is equal to 0 1, then the second AND gate is enabled and the remaining all other AND gates are disabled. Therefore the data bit I1 is transmitted to the output and it is giving y is equal to I1 into S0 bar, sorry S bar S0 bar, I1 into S0 S1 bar. When applying a S0 S1 is equal to 0 1, then the third AND gate is enabled but all other AND gates are disabled. Therefore it gives the output y is equal to I2 S0 bar S1. The next whenever applying S0 S1 is equal to 1 1, then fourth AND gate is enabled and the remaining all other gates are disabled. Therefore it gives the output y is equal to I3 S0 S1. So by using this output of y, you can draw the logic diagram of the 4x1 multiplexer. So here S0 S1 are the control inputs. I0 I1 I2 I3 are the different inputs. So you can draw I0 S0 bar S1 bar and draw the AND gate. Next take another AND gate, I1 S1 bar S0, and draw the AND gate. Plus you can draw another output, that is I2 S1 S0 bar, and finally you can draw another output, I3 S1 S0, fourth AND gate. By combining this all the AND gates with OR gate, and we get the final output, that is y. So this is about the 4x1 multiplexer. Next applications of the multiplexer. Multiplexers are used in various fields where multiple data need to be transmitted using a single line. So following some are the important applications of the multiplexer. It is widely used in a communication system, telephone network, computer memory, transmission from one computer system of a satellite, and it is used as a data selector, and it is used for a parallel to serial converter, and it is used for a waveform generator. So this is about the 4x1 multiplexer. Next I am discuss about the demultiplexer. Demultiplexer means one into many. The demultiplexer performs the reverse operation to a multiplexer. It takes data from one line and distributes it over number of output lines, hence the name as a data distributor. And here multiplexer is the data selector. The logic diagram of the 1 into 4 demultiplexer. There are different types of demultiplexer, like 1 into 4, 1 into 8, 1 into 16, etc. So now we discuss about the 1 into 4 demultiplexer. So here 1 is the output line and 4 are the different output lines. So that is input line is D, and D0, D1, D2, D3 are the different output lines, and the control inputs S0 and S1 here. The truth table of the demultiplexer 1 into 4 demultiplexer as shown in above. So here input is DIN, selectors A and B here, and outputs D0, D1, D2, D3. So when applying so here the demultiplexer has one input and 4 output lines. It accepts a single input and send it to one out of 4 output lines, which are selected by control lines. That is here A and B. It may be noted that the data input lines goes to all of the AND gates. The truth table when both of the selection lines A and B are at 0. The first AND gate is enabled and all other AND gates are disabled. When both the selector lines S1, IA and B are at 0, 1, the second AND gate is enabled and the remaining all other gates are disabled. When selector lines A and B are 1, 0, then third AND gate is enabled and the remaining all other gates are disabled. Finally, when selector lines A and B are at 1, 1, then the fourth AND gate is enabled and the remaining all other gates are disabled. So from the truth table, D0 is equal to A bar, B bar, D, and D1 is equal to is A bar, B, D, and Y2 is equal to A, B bar, D, and finally D3 is equal to A, B, D. So by using this outputs, we can draw the logic diagram of the 1 into 4 demultiplexer. So here data input is D and selector lines A and B, and from that selector lines we can complement both the lines with NOT gate. We can draw the according to the above outputs. So here D is the single input and it gives 4 different outputs, that is Y0, Y1, Y2 and Y3 here. Next application of the demultiplexer. Demultiplexer is used to connect a single source to multiple destinations. The main applications of demultiplexer is listed in below. In communication system, ALU, arithmetic logic unit, and serial to parallel converters. Here the main difference in between multiplexer and demultiplexer. Here multiplexer allows multiplexer allows many inputs and single output, and here the demultiplexer allows accepts only one input line and gives different outputs. So it is the multiplexer is the data selector and the demultiplexer is the data distributor, another name. And here multiplexer is the parallel to serial converter, and a demultiplexer is the serial to parallel converter. So multiplexer commonly used in following applications like communication system. Communication means connect the communication point in between any 2 points or communicate the information in between any 2 systems or 2 person or any 2 devices. And a telephone network, computer memories, transmission from the computer system to satellite. And here demultiplexers are widely used in different applications. So mainly used in same communication system, ALU, arithmetic logic unit. It is the heart of the computer, and it is used in serial to parallel converter. So this is the explain about the multiplexer and the demultiplexer functions, and multiplexer and demultiplexer important applications used in real life and in different communication systems. And among that two, one is the selector and another is the distributor. So multiplexer is the selector and demultiplexer is the distributed device. Thank you.